Hello, my name is Pete Kendrigan. I am here to present the latest version of Florida Near Shore's Tri-County Charts and Maps program version 4.31 of November 2016. This is a program designed to visualize the ocean floor profile, from the shoreline out to a depth of 150 to 200 feet. All charts and maps are presented with their shoreline at the bottom, equals west, seaward at the top, equals east, north is to the left and south is to the right. This is Broward County chart number B01. This is a mosaic view of Palm Beach County. On the left side is the Martin County/Palm Beach County line. Our data starts here at chart/maps P01 and P02 and continues south to the southern end of Miami-Dade County. Our bottom depth limitation, due to laser depth sounding capabilities, is in the range of 150 to 200 feet. That limit lies 3.5 to 4 nautical miles offshore in this area. Therefore, we require two west to east chart/maps to cover it. These are namely, P01 for the near shore area and P02 for the offshore area. As we proceed south to other chart/maps, this depth limitation comes closer and closer to the shoreline. Starting with P05N, we only require one west to east chart/map. At the south end of Palm Beach County is P11. Then we enter into Broward County. This is a mosaic view of Broward County. Its north end begins at chart/map B01, near Boca Inlet. Its south end is at chart/map B07, near the Miami-Dade County line. This is a mosaic view of Miami-Dade County. Chart/map M01 is at the north end. Chart/maps M08/M09 is at the southern end. The Fowey Rock and Brewster Reef area, circled in red, on chart/map M09, extends our coverage slightly into Monroe County and ends at Brewster Reef. Due to inclusion of Government Cut and the eastern portion of Biscayne Bay, two west to east chart/maps are again required for points south of M03. To summarize the three previous slides. 1. Our Tri-County Charts and Maps program covers 3 counties, that's over 80 nautical miles of coastline and 1.26 degrees of latitude. They cover from the shoreline out to 150 to 200 feet of water depth. 2. There are 28 high-resolution color graphic maps with precisely separated, 1/2 mile grids, located on every major 0.500 degrees of latitude/longitude. These are provided for use in identifying currently non-annotated features. 3. There are also 28 high-resolution color graphic charts containing well over 1,000 annotated dive/fishing site locations. Note, for visual clarity, we show uncluttered map views. Using the chart views, which contain specific site information with arrows pointing to them, would have distracted the viewers from what we wish to show in this section of our presentation. This is a view of the upper 1/3 of the program's opening page. As a first-time user of this software, all 3 sections of this page should be read at least once, since it explains all the tools required to navigate through the topics. There are 5 main navigation tools called interactive buttons shown within the brown background boxes. They are labeled left to right as FNS products, chart overlays, map overlays, PDF books, and tools. In the lower, program startup steps area of this page is a flowchart consisting of 4 columns. Left to right they are, column 1, Windows instructions on where to find the chosen USB slot, our example equals drive F, then, a green pointer to a sample drive C view. Column 2, a typical drive C view in which one sees the label C and M4.xx parenthesis, F:, our TD program. Column 3, Windows instruction for the TD. Its directory is shown in column 4. Column 4, the TD directory whose use will be discussed on the next slide. This single TD contains 3 different operating system programs. They are, Windows, 7 to 10, MacBook Pros with OS X Capitan version 10.11.6 or higher and most Android tablets beta version. Note, the current Android tablet version is not recommended nor supported. It has severe limitations due to small screen sizes and not being a runtime software package like the Windows and MacBook programs. The following slide will explain this in more detail. This slide shows the three possible startup sequences, one for each of the three previously mentioned devices. This necessitates three distinct startup procedures. Let's first examine the Windows 10 procedure. Insertion of the thumb drive into an active USB slot should open the thumb drive startup folder on the TD. Note, if not, check your PC autoplay settings in the control panel. Assure that the software setting is set to install or run program from your media. Now, in column 1, at the bottom, is a Windows icon labeled Start. Double-clicking on it will run the Windows version of the software. On a MacBook Pro, one must also insert the TD into an active USB slot which sees the application, and places a C&M 4.3 icon on its display. Double-clicking on this icon will start the MacBook Pro version of our program. On the beta Android tablet version, one must have a special USB, OTG, cable interface and Flux Player software installed on an external memory chip. We do not recommend use of this type system with the currently available Android systems. There are 4 other informational, non-startup related items, in the Startup folder column. They are the License folder containing the end user's license information, a ZData folder and 2 DLLs. This is the middle section of the program's opening page. There are 4 major points discussed here. 1. There are both chart pages and map pages. The chart pages may be both viewed and printed. The map pages are viewable but are not printable, they are used only for the precise locating of non-annotated DGPS features. 2. The chart pages may be printed by clicking on the print symbol which is located in the upper left corner of the display. See the yellow arrow just below. 3. The chart and map pages are exited, or closed, by clicking on the left arrow symbol also located in the upper left corner of the display. See the red arrow just below. 4. Never click on the X in the upper right-hand corner of either a chart or map page. That action would close the program. See the blue arrow just below. This is the bottom section of the program's opening page. It simply explains an inconsequential bug left over from earlier editions of the Miami-Dade County and Palm Beach County PDF books. It should be simply ignored since it has no negative effect on program operation. If desired, it may be temporarily removed from view by clicking on the green arrow at the right end of the notification bar. Now, let's go to the program itself. Here we are at the program opening page from which all procedural steps are taken. One simply clicks on one of the 5 link bars, i.e. interactive buttons, to select the desired topic. Let's take a quick look at the available FNS products by clicking on its interactive button located by the red arrow. This is the FNS products page. Before we get to our product listing, please note the Home interactive button by the red arrow at the top of this page. Clicking on that interactive button will return one to the program's opening page from any topic. Now, to our FNS product listing. 1. Tri-County Charts and Maps program. This is the basic charts and maps package for those not requiring an onboard navigational software system, as described in package number 2 below. For owners of product number 1, this product, clicking on the blue Read This Program Tutorial interactive button pointed to by the blue button above will take you to a 35-minute video explaining the features of this software package. An internet connection is not required. Note, the tutorial is also available to those not owning the software. Tell your friends to go to YouTube on the internet and search for the term Tri-County Charts and Maps. Use the listed web address in the search box. The video may also be viewed on the Dixie Divers webpage. 2. Tri-County Nearshore and GPS Tracking Utility Program. This product is one which has been very successful over the past several years. It is being used mainly by serious scuba divers and industry professionals. It features a live GPS interactive package allowing one to visualize the ocean bottom profile while navigating to any site within our range of charts. We have sold over 300 units. If enough written interest is expressed, they may be made available later this year for a reduced price of $100 plus shipping costs, until our supply of special TDs is exhausted. Orders will be shipped from our temporary residence in Minnesota. Now, let's return to the opening page of our program. This once again is the program opening page. Now, let's click on the Chart Overlays interactive button, located by the red arrow above, to see what it provides the user. This is the Tri-County Chart Overlays page. It contains 3 interactive buttons, one for each county. As previously described in the mosaic views, there is a listing of 28 charts, 7 in Broward County, 9 in Miami-Dade County, of which 6 are combined into 3 chart set pairs, and 15 in Palm Beach County. Note, the diagram at the lower half of this page shows how one may fit a chart to the display and zoom in and out to explore specific areas. Now let's take a look at the Broward County charts mosaic view of its 7 charts by clicking on its interactive button, pointed to by the red arrow above. This is a mosaic view of the Broward County charts, B01 through B07. Position your pointing device inside the chart label, here B01, and click to open its PDF image. See the red arrow. This is chart number B01. It shows the offshore bottom profile from the Boca Hotel, which is located near the Broward/Palm Beach County line, to northeast 54th Street, located near the Deerfield Beach/Lighthouse Point line. It covers a distance of approximately 3 nautical miles, 18,000 feet, in latitude, i.e., north to south direction. This, and all charts, may be printed by clicking on the printer symbol shown by the white arrow in the upper left corner of this display. On this chart there are 21, quote, known to me, dive sites with their respective DGPS coordinates. The known to me comment, wherever mentioned in this presentation, signifies that I have personally dove the site on one or more occasions. This is a 200% zoomed in view of the popular quadruple wreck dive site from chart number B01. It shows the Sea Emperor, the United Caribbean, now in 2 pieces, the Nula Express and the Miracle of Life, added in 2009 by a group sponsored by Dixie Divers. To give a further example of the details achievable in this program, this is a 1500% zoom of this chart. That is, the full size, 18,000 feet in latitude, divided by, this size, 1,200 feet in latitude. That value times 100% equals 1,500%. 10-second pause. Once again, we are back on the program opening page. Let's now take a look at the Map Overlays page by clicking on its interactive button pointed to above by the red arrow. This is the Tri-County Map Overlays page. It contains 4 interactive buttons, one for each county and one for new dive sites added in 2016. As previously described in the mosaic views, there is a listing of 28 maps, 7 in Broward County, 9 in Miami-Dade County and 12 in Palm Beach County. Also, there are 3 new features added in 2016. Note, the diagram at the lower half of this page shows how one may fit a map to the display and zoom in and out to explore specific areas. Now let's take a look at the Broward County Maps mosaic view of its 7 maps by clicking on its interactive button, pointed to by the red arrow above. This is a full screen view of map number B01. This is the same image as shown by the chart number B01, but with all of its overlying dive site labels and arrows removed. The purpose of a map view is to allow one to have unrestricted visibility of all areas of the image. One may zoom into any one of the more than 20, precisely defined, 1/2 mile square area, rectangular shaped grids. These grids lie on the major 0.5 mile separated latitude/longitude coordinates of the map. You will see this data in the margin of all maps. Here, one may precisely measure the geographic coordinates of any currently undefined feature using the JRuler Pro device, Pixel Stick device on MacBook Pro device, when it is aligned within these grids. More on that subject when we get to the tools section of this presentation. Note, printing is not allowed nor desired except by using the window snipping tool and the screen capture device on MacBook Pros. Let's take a quick look at a zoomed-in area of this slide. This is a zoomed-in view of a popular dive site map image so one may see the difference between a chart view, on the next slide, and this map view of the same area. Note that the known to me locations are still identified by smaller labels at their locations. Let's take another quick look at that chart view and then return to the Tri-County Maps page. This is the chart view referred to in the previous slide. It is a 200% zoomed view of a popular dive site from chart number B01. This once again is the Tri-County Map Overlays page. Besides the 3 county map folders, there is a folder showing details of 3 new features added in 2016. Let's go to them. These are the 3 new dive sites added in 2016. In the left-hand column is the Anna Cecilia, a 160-foot vessel sunk just outside Lake Worth Inlet. Our map pages will show it on Palm Beach County Map P05SA. Below this partial view are its GPS coordinates, a description of its sinking and a link to where one may see a YouTube video. In the center column is the Rapa Nui barge and 2 associated rock piles. This partial view of Map B01 in Broward County details this feature's coordinates and their relative direction/distance from the barge. Below the coordinate listing is a description of the site followed by a link to a YouTube presentation. In the right-hand column is the Lady Luck wreck located in Broward County on Map B03. This is a 324-foot tanker sunk on July 23, 2016. This ship is the centerpiece of what will become known as Shipwreck Park, surrounded by 16 other existing wrecks covered with marine life. Due to its size, we give 2 sets of coordinates, the stern facing north-northwest and the bow facing south-southeast. Now, let's return to the program's opening page. Once again we are back to the program opening page. Now, let's go to the PDF Books section by clicking on the interactive button located by the red arrow in the above view. This slide outlines the content of all 3 Tri-County PDF books. The lower, small print area of this page contains a sample reference index of each PDF book. A comprehensive index is contained within each PDF book. The books vary in length dependent on the number of charts they contain and, even more significantly, the number of blow-up images each contain. Broward has 132 pages. Miami-Dade has 60 pages. And Palm Beach has 149 pages. Let's go to the Broward County PDF book. This is the cover page of the latest 132-page Broward County Nearshore PDF book. It is the 8th edition from January of 2011. It is based on the Broward County Natural Resources Planning and Management Division's 2008 LAD survey. The PDF books, due to their size, are too extensive to be fully covered in this presentation. However, we will show one of several, highly useful, advanced features. This is page 11, the first chart page. The feature we will show is the ability to blow up, i.e. zoom in, on any one of the known to me dive sites to show more detailed information. That capability is beyond the scope of a simple PDF chart. Let's take a look at a partial view of this chart, the Sea Emperor area, located in the brown box by the white arrow of this view. This is a partial view of page 11 showing the popular Sea Emperor dive site, which is close to 2 other popular sites, the Nula Express and the United Caribbean. The Adobe Reader's cursor, shown above to the left of the red arrow, when positioned over this object's name, changes shape from a normal closed hand symbol to a pointing finger symbol. When clicked, a blow-up of this page is displayed. See the next slide. This view contains details specific to the Sea Emperor/Triple Wreck area. Namely, 1. The Sea Emperor's location, i.e. distance and bearing from the nearest north and south access from departure ports. 2. Its surrounding water depth and critter population plus information on nearby sites such as their distances/directions from each other. 3. Specific cautions related to the site such as the normally to be expected current, both speed and direction. 4. Remarks concerning the vessel's condition at the time of this book's publication. From this view one may also directly click on other blow-ups as long as their names appear capitalized in the current view. In this blow-up there are two, the Nula Express and the United Caribbean. To return directly to a main page from any one blow-up view, simply click on the blue-colored label named Back. Its location is at the bottom, center of each blow-up view. See the red arrow in the slide above. Note, the yellow arrow in the sidebar points to ways the Adobe Acrobat view may be altered, i.e. zoomed in and out, etc. This once again is the program opening page from which all procedural steps are taken. Now, let's examine the Tools page by clicking on its interactive button located by the red arrow above. This is the Tri-County Tools page. There are currently 5 topics. They are described briefly in the paragraphs shown below the interactive buttons. On the left is the Read Me First interactive button, which takes one to a 2-page document which should be printed out for reference. Please take time to completely read this page, at least once. The only other interactive button whose action we need to discuss is the JRuler Pro section. This is our recommended method for defining/locating undersea features which are not already geo-referenced. This method works well on Windows systems, but its feasibility has not been fully explored on iMacs or Android systems. Note: the following 2 supplemental page slides are not included in the JRuler Pro section. They were added by me as an introduction to that discussion. Let's go to them. This once again is the Tri-County Tools page. This interactive button, whose action we need to discuss, is the JRuler Pro section. This is our recommended Windows method for defining/locating undersea features which are not already geo-referenced. Note, the following 2 slides are not included in the JRuler Pro section. They were added by me as an introduction to that discussion. Let's go to them. This is supplemental page 1 of 2, an example of georeferencing an undocumented site. This is the Broward County map number B05, where we want to locate/define a dive site. All we know from our dive is 3 facts. They are: 1. No GPS information was recorded, but we recall we were using map number B05. 2. The site was seaward from the Yankee Clipper Arrowjack Reef. 3. Our dive was on a feature near the north end of this map in 40 to 60 feet of water. To accomplish our goal, we must: A. Zoom in on an appropriate area of the map. B. Find the Yankee Clipper Arrowjack Reef. C. Look seaward to find our range of water depths. With that information alone, let's zero in on the closest 1/2 mile square and rectangularly shaped grid, where the site is most probably located. See the white labeled text in the previous slide indicating the target's most probable area. This is supplemental page 2 of 2. We determined, by observation, that the only feature fitting our description is the one within the blue circle of this zoomed-in view. Since, 1. It is the only recognizable/probable feature in this area, one we would have explored, if known about. Also, as one can barely see, it is a raised bottom feature of appropriate size. 2. It is close to the 60-foot seaward drop-off ledge, which also fits our general recollection from our dive. The red grid lines on all our maps are located precisely at 0.5 degrees of latitude and longitude. We take note that our grid of interest has a southeast coordinate intersect of 2606.5 degrees north latitude, and 8005.0 degrees west longitude. See the red circle in the above slide. With that information at hand, we can now more precisely determine the site's position, i.e. target location. We are now in the JRuler Pro section of our program. This slide describes how one determines that the target is at 2606.657 degrees north latitude. With the map's target zoomed in on the center of your computer screen so that the grid of interest is occupying, at least, more than one-half the screen width, call up the ruler and position your cursor on the scale and over the word, pixel. Use your mouse wheel to rotate the scale to a horizontal orientation with its zero end to the right. Precisely position the zero end on the latitude intersect of 2606.5 degrees using the keyboard up, down, left and right arrow keys. Then elongate the scale so its max end is precisely on the next more northern grid latitude of 2607.0 degrees. Do this using the scale's resize command. For this example, the symbol is located at the upper left corner of the scale. This creates a scale length of 530 pixels, read by moving one's cursor slowly over the scale past its max end and recording the scale X value. The scale is then vertically positioned up or down using the keyboard up or down arrow keys so that an edge is near the target. By observation, i.e., moving the cursor carefully along on the scale's edge closest to the target, we find it is at 166 scale pixels, a new X value. By calculation, the target's latitude is equal to the base latitude of 2606.5 degrees plus 0.5 times the expression, 166 pixels divided by 530 pixels, equals 2606.657 degrees north latitude. Why the 0.5 in the calculation? The grids are precisely 0.500 degrees in separation. Therefore, the scale percentage of 166 divided by 530 must be multiplied by 0.5 to make the result a percentage of 1 whole degree, not 1/2 degree. Notes: 1. Positioning the cursor over the word pixel on the scale while rotating it, minimizes undesired scale movement on the screen while making scale rotational position adjustments. 2. One should note that we have taken steps in explaining which keyboard keys should be used in each step. Using other key combinations may cause confusion. This slide describes how one determines that the target is at 0805.229 degrees west longitude. With the map's target zoomed in on the center of your computer screen so that the grid of interest is occupying, at least, more than one-half the screen height, call up the ruler and position your cursor over the word pixel on the scale. Use your mouse wheel to rotate the scale to a vertical orientation with its zero end at the top, east, direction. Precisely position the zero end on the longitude intersect of 0805.0 degrees using the keyboard up, down, left and right arrow keys. Then elongate the scale so its max end is precisely on the next more westward grid longitude of 0805.5 degrees. Do this using the scale's resize command. For this example, the symbol is located at the lower left corner of the scale. This creates a scale length of 499 pixels, read by moving one's cursor slowly over the scale past its max end and recording the scale Y value. The scale is then horizontally positioned left and right using the keyboard left and right arrow keys so that one edge is near the target. By observation, i.e. moving the cursor carefully along the scale's edge closest to the target, we find the target is at 229 scale pixels, a new Y value. By calculation, the target's longitude is equal to the base longitude of 0805.0 degrees plus 0.5 times the expression, 229 pixels divided by 499 pixels, equals 08005.229 degrees west longitude. Again, why the 0.5 in the calculation? The grids are precisely 0.500 degrees in separation. Therefore, the scale percentage of 229 divided by 499 must be multiplied by 0.5 to make the result a percentage of 1 whole degree, not 1/2 degree. Notes: 1. Positioning the cursor over the word pixel on the scale while rotating it, minimizes undesired scale movement on the screen while making scale rotational position adjustments. 2. One should note that we have taken steps in explaining Which keyboard keys should be used in each step? Using other key combinations may cause confusion. For the third time, we are back at the program's Tri-County Tools page. The Pixel Stick Screen Ruler software for MacBook Pros is the closest we could find to the Windows J Ruler Pro. This folder contains an 11-page PDF document describing the usage of this software on MacBook Pro PCs. The principles are the same. 1. Record the 1/2 mile coordinates, i.e. the base numbers, to the south and east of your target. 2. Define the number of pixels per 1/2 mile in both latitude and longitude direction. 3. Measure target pixels as percentages of 1/2 mile grids. 4. Divide results in step 3 by 2 to convert them into percentages of 1 mile and add to base numbers. 5. Double check your results. For the fourth time, we are back at the program's Tri-County Tools page. The Mylar template folder contains a printable interpolator example and a blank template page which we recommend be printed on Mylar for use as an overlay to a printed map. This is an example of a filled-in interpolator from the Palm Beach County's Jewfish Mound site. The idea is to measure, with a pair of dividers, the target's position both north and west of a set of known coordinates and transpose them to a blank interpolator form. One could then translate those measurements into their percentages of a 1/2 mile grid and apply the results. To me, the on-screen ruler is a much better tool. This is a printable blank template with instructions for use. Please feel free to print as many copies as you wish. For the fifth time, we are back at the program's Tri-County Tools page. The Tri-County Tools MacBook Pro's Startup folder contains information relative to what happens when one inserts a thumb drive into an active USB slot on a MacBook PC. When one inserts our thumb drive, TD, into an active USB slot on a MacBook PC, the Mac system adds it to the display the icon C and M4.XX, where the XX is the current revision number. See the red circled area below. Then, when one double-clicks on this icon, our software loads and displays the following image on the MacBook display. Finally, when one double-clicks on the multicolored start icon, circled in green above, our software program begins at its main page as seen in the following slide. This is our final slide and it contains a few reminders. 1. This program is delivered on a 4 GB, copy-protected, encrypted and proprietary thumb drive simply referred to as ATD in this presentation. 2. It is available only through authorized distributors. 3. It functions on all three major computer systems, namely, Microsoft Windows 7, 8 and 10, MacBook Pros with operating system OS X El Capitan version 10.11.6 or higher, and most Android devices having full, OTG, on-the-go, USB compatibility. Important note, as of this software release, we do not recommend use of this program on Android devices. We do not support nor warrant its use on those devices. 4. All devices must have an active and unoccupied USB slot. On an Android device, the mini USB/power adapter serves as the TD connector. 5. The TD must continuously reside in the USB slot while the program is running. 6. One may return to the program's opening page by clicking on the Home Interactive button from any page. 7. To exit the program, one simply clicks on the X in the upper right corner of your computer screen from anywhere within the program. That concludes our presentation. Thanks for your attention. If this is a live session, please see me after we take a short 5-minute restroom break for any questions you may have. For remote web presentations, please call me at 561-523-6253 during normal business hours, 9 a.m. to 4 p.m. CST. Alternately, one may text me at my cell number or email petekendrigan@gmail.com. All messages will normally be answered within 24 to 48 hours.